In our very first video, we're going to introduce the complex numbers. So throughout the entire course, n, z, q, r, and c are going to be the standard things. So natural numbers, integers, rationals, real numbers, and complex numbers. We're not going to go through the construction of the real numbers from Q, but we will define the complex numbers in terms of the real numbers, and we're going to do that now. So a complex number, and let's highlight this, is a number or a symbol of the form. It's an expression, I guess. A plus bi, where a and b are real numbers. So you have to have seen complex numbers by now, but as a reminder, that's what that is. And the set of all complex numbers is denoted with this blackboard font C, and it's just the collection of all symbols that look like this. Okay, so that's what it is set theoretically, but there is ring structure that we can put on C, and it arises by really the addition is just combined like terms, and the multiplication arises by setting I squared to be -1 and then just carrying out the distributive property. So that is the addition is, well, if we have two complex numbers, a1 plus b1i and a2 plus b2i, their sum is combined like terms, so a1 plus a2 and then b1 plus b2i. And the multiplication is what you get when you apply the distributive property. Let me scroll down a bit more. So a1 plus b1i times a2 plus b2i is, all right, so what do you have to do? Well, there's a rule that I could write down, or we could just multiply it out. So if we FOIL, we get a1, a2 plus, and then assume that multiplication of real numbers and this symbol I commute, a1, b2i, a2, b1i, and then b1, b2i squared. But I squared is -1. So if we replace this guy here with a -1 and collect all the symbols that don't have an I with the symbols that do have an I, then we have that rule. Now don't ever remember that rule. Just remember that it's just foiling where I squared is -1. Okay. So this is the set C of complex numbers, and these are the two operations, addition and multiplication. In the next video, we are going to prove very rigorously that this forms a commutative ring. In fact, it forms a field. For now, let me notice there is a non-ring, a structure that's not related to it being a ring, a function. There's an additional operation of complex conjugation. So it's typically denoted by bar. So if I take a complex number, something of the form a plus bi, and we put a bar over it, that's called the complex conjugate, and what you do is you negate the imaginary part. We're going to see conjugation, or this idea of conjugation, or swapping. I is like the square root of -1, swapping a square root with its negative I being the negative square root of -1, is going to show up a lot. It's going to be a common theme. We're going to look for, in some sense, we're going to try to look for these sort of conjugation operations a lot later. But there is this additional operation of conjugation, And lastly, in this first video, all we're going to say here is that if we have a complex number, then A, the portion without the I, it's called the real part, and B, the real number that's attached to the I, not BI, B on its own, is the imaginary part. And so with these definitions of the components of a complex number, the operation of complex conjugation is the negate the imaginary part operation.